Okay, the number line, something people learn in second or third grade and then never think of again because they get a calculator put in their hands. So we just start with a little straight line, make it as straight as I can. Okay, there's a line. Okay, we put an arrow on it to indicate a positive direction. And then we locate 0 on the line. I'm going to locate 0 somewhere in the middle. And we locate 1. Having located 0 and 1, we mark off equal intervals for 2, 3, 4, 5, 6, etc. And we go in the opposite direction, trying to keep the intervals equal. I'm not very good at doing that. -1, -2, -3, -4, -5, -6. Better than I usually do. You can do better. Okay, so there's a perfectly good number line. Another way to make it is decide how big the numbers you want to represent. And we could put like 0 here. We could put 16 here. -16 here. And then we can subdivide, and this makes it easier to keep our intervals equal. So I can subdivide this interval. If I can find the halfway point between 0 and 16, I know I've got 8. Halfway between 0 and -16 should be -8. Let's see how I did this. -8's a little too far this way. Should be maybe about there, and then that interval and that interval. Okay, it's not great, but we'll make the best of it. Okay, then I can subdivide again. Giving me 12, 4, -4, and -12. I think get a little cramped here. We do a really good job of that. Okay, then we can subdivide again. And that would give us the numbers -14, -12, -10, -2, 2, 6, 10, 14. And any more subdivision, be hard to label at this on a graph of this size, but they're my units. So these would be my odd numbers, and it's pretty clear if you know what the numbers are that have been labeled. It's pretty clear what the marks in between mean. Okay? So, a couple of different ways of doing it. Now, what good is a number line? Well, the number line allows you to visualize addition, addition and subtraction. Okay? Now, the first thing I want to talk about is subtraction. So, let's say we want to represent 5 minus 2 on the number line. Okay? So, let's say 5 minus 2. Let's find 2. And let's find 5. Of course, we know that 5 minus 2 is 3. 5 minus 2 is the displacement from 2 to 5. So we draw an arrow from 2 to 5, and this arrow represents 5 minus 2, and we can see how long the arrow is. 1, 2, 3. 5 minus 2 is 3. Okay? Now let's say we want to do -5 minus 1. Here's my 5 minus 2. -5 minus 1. Okay, well, what number did we start at when we drew this arrow? We started at 2. Okay, we started at the number that's being subtracted, and we moved toward the number that we're subtracting from. We're going to do the same thing here. Okay, we're going to start at -1, and we're going to move to we're going to start at 1, and we're going to move to -5, because we're subtracting 1 from -5. Okay, so we start at 1, and we move to -5. Okay, so that's the arrow that represents -5 minus 1. Okay, you want to think of addition and subtraction in terms of arrows on the number line. That's all I'm going to say about it right now. Especially when you're doing small numbers, visualize them. Single-digit numbers, visualize them on the number line, whether positive or negative, and reconcile the arrows that you would draw on the number line with the answers you get if you follow the algorithms you've been given, or if you, heaven forbid, put them into a calculator.